All right, for number 1, it says, when does the particle change directions? If you look over here on the right side, you can see that we have our chart filled out for us already. At the bottom, we have all the times. So there's a beginning time called A and an ending time called B. And there are 2 critical numbers in between there. And so that's where our derivative is either 0 or undefined. You'll see that we tested in between the critical numbers and the endpoints, and we got the values for our velocity. The important thing about this question is that if your velocity is positive, then it means your particle is moving to the right. So you can see when your velocity is positive, the particle is moving to the right. And when your velocity is negative, your particle is moving to the left. So you can see at this first critical number, we do not change directions because we're going right. And then the velocity is 0 or undefined. And then we're going right again. So we did not change directions. At the second critical number, we do change directions because we're going right. And then at that moment in time, we change and now we're going left. So to answer this question for number 1, when does the particle change directions? It would be at this critical number right here. And again, this is all theoretical right now. We don't have the actual time for that spot, and we don't actually even know the velocity function or the position function. So this is more of a conceptual example. We're going to go through these and just look at a bunch more that are similar to this. So here's our second example. It says, when does the particle reach its highest point? And then also, when does it reach its lowest point? So instead of going left and right, we are going up and down. And usually when we go up and down, it's called y of t, not x of t. But in this example, they are calling it x of t. So this is basically just the same chart, but instead of going right and left, we're just going up and down. First thing says, when does the particle reach its highest point? And based on this chart, it's pretty easy. It's just going to be at this spot right here. So this critical number over here. Remember, your critical number could be either where your derivative is 0 or where your derivative is undefined. So we're going up, and then we're going up again, and then we start going down. So the question says also, where does the particle reach its lowest point? So it would have to either be at the end of the interval where we're going down, or it could be at the beginning before you start going up. Either one of those could be the lowest point. So what's happening here is we're going up and then we're going down. So that could happen, or we could go up and then we could go down a lot more. So I think you can see that in the first example, the lowest point was the beginning. And for the second example, the lowest point was at the end. But no matter what, your max and your min will always happen at either the endpoints, if it's a closed interval, or at one of your critical numbers. All right, let's take a look at our third example. When is the particle furthest to the right? So this is pretty easy. We're just going right, and then we go left. So when are we furthest to the right? Well, it's at that spot where you change and start going left. So it would be at this critical number. That's a pretty easy one. When are you furthest to the left? Well, that's going to take a little bit more investigation. It could be at the beginning before you start going right, or it could be at the very end because we don't know how far left you went. Maybe you went really far to the left. So when is the particle furthest to the left? Well, it'd have to be at one of these 2 endpoints. All right, let's look at the last example. This last example is a pretty basic example. It just says, when is the particle moving to the left? And that would be when your derivative is negative. So on this time interval right here, our particle is moving to the left. Another question is, when is your particle moving to the right? Well, anytime your derivative is positive, so whenever your velocity is positive, it means that your particle is moving to the right. And that's pretty much it. This is a pretty basic example. I think the only thing that might be a little bit tricky is just filling out this chart. So let's talk about the chart real quick before we go. The bottom row is all the times. So you have the beginning endpoint and the last endpoint. And in between, there's a couple examples of critical numbers. You want to test in between all those numbers to see if you get either positives or negatives. If you get positive for your velocity, it means that your particle is moving to the right. If you get negative for your velocity, it means that your particle is moving to the left. And that's pretty much it. So using this knowledge, we should be able to do the examples that we have for homework number 94.